All right, I'm about to go over a quiz we had over circles, and this has a good sampling of different things to do with graphing circles in the coordinate plane and their equations, looking at their equations. And so if that's something you're looking to go over, this is a pretty good overview. First thing, let me just talk to you about the basics. The equation of a circle in the coordinate plane, written in standard form, looks like this. Okay? X minus h, and that quantity is squared, plus y minus k, that quantity is squared, equals r squared. So h and k are the center of the circle. And r stands for the radius. Okay, so if r stands for the radius, then this is the radius squared. Every time you see this in the equation, anytime you see the part about the radius in the equation, it's squared. When it's not in the equation, there's no reason to square it. If we're just talking about what the radius is, or maybe graphing, or looking at the graph, then it's just the radius. But in the equation, it's the radius squared. So if I'm taking the radius and putting it into the equation, I have to square it. If I'm taking it out of the equation, I have to take the square root. Another thing is, since both of these are x minus something, or could be plus something squared, but because they have a minus, whatever you see here, for instance, if we have this, whatever you see right here, you're going to say the opposite sign when you're talking about h or k. Because if it's minus in front of this, well then k is 1. But if it's minus in front of this here, and I don't see a minus, that means what I originally had would have been x minus a negative 5. That's why I have a plus, is because h is negative 5. So the h and the k are always the opposite sign from what they appear to be looking inside the parentheses. Also, just going with what we just said a second ago, if the radius squared is 10, how would I solve that? Take the square root of both sides. So the radius is square root of 10. This is a case where we don't need to do plus and minus because radius is actually a distance or a length, so it's not going to be negative. All right, so looking at number 1 here, it says identify the center and radius of each, then sketch the graph. All right, if I don't see a plus or a minus with my x, that means that basically what I've had is x minus 0 squared. Same thing for y. Y minus 0 squared. And I don't have to write the 0 because x minus 0 is just x, or y minus 0 is just y. Again, this is the radius squared, so that's the same thing as 3 squared. So my radius is 3. The center here is 0, 0. So every time it's 0, 0, because we don't have to write x minus 0 and y minus 0, you'll just see x squared plus y squared. And every time you see just x squared plus y squared and no other x's and y's, that means your center is at 0, 0. All right, so 0, 0 is the center. The radius is 3. That means I'm going 3 in every direction from this point. So the easiest way is just to go up, down, left, right. 1, 2, 3. 1, 2, 3. To the left, 1, 2, 3, and down 1, 2, 3, and then draw a circle through those points. That takes some practice, and mine isn't perfect, but it might be better than yours in the first few tries just because it takes some practice to draw that circle. And that's the answer to number 1. Okay, number 2. This time you don't just see x squared and y squared, which means the center is not going to be just at 0, 0. The center is going to be at positive 3, positive 3. Remember, if you see a minus, that means it's actually the opposite. X minus h, if you're seeing minus 3, that means h is 3, k is 3. So my center here would be 3, 3, which is right here. My radius, this is the radius squared, remember. So if the radius squared is 4, Take the square root of that and you get 2. So the radius is 2. So I'm going to go 2 in every direction from the point 3, 3. So 2 to the right, 2 up, 2 left, 2 down, and draw a circle through those points the best that I can. All right. Numbers 3 and 4, I'm starting with the info and writing the circle. It says use the information provided to write the equation of each circle. So if this is my center, then this is H and this is K. All right, so since I don't have much space here, let me just go ahead and do my work on another page. That means X minus H, Y minus K. Again, this is why we see the opposite sign, because minus a negative is actually plus. So I'll see plus 15 and plus 8. Now, if the radius is square root of 7, that means I'm plugging that in and squaring it. R squared means square root of 7 squared. Well, if you square a square root, that basically just lifts off the square root. It's like doing two opposite things to something. All right? And I get 7. So in the equation, it'll just say 7. So that's my answer. Another way to look at this is if my radius is square root of 7 and I want the radius squared, squaring a number means multiplying it times itself. Square root of anything times the square root of that same number is just the number, because that's what square root means. It means a number that if I multiply it times itself like this, I just get that number. Or you can think of it as 7 times 7 is 49, and then what's the square root of 49? 7. Okay, number 4 works the same way. My H is -5, my K is 1. So X minus -5 is going to become X plus 5. Y minus 1 squared isn't going to change. Now the only difference on number, excuse me, I'm off the screen here. The only difference on number 4 is they didn't give me the radius. There's two things you need to write the equation of the circle. You need the center and you need the radius. I don't have the radius, but I do have a point on the circle. So let's look at what's happening here. If I know that I have a center of -5, 1, and a point on my circle is 2, 2, then the radius is the distance between them. And that's not the most accurate graph, but the distance between them is my radius, and that's what I need. So I could use the distance formula, but it turns out that the circle formula, the standard form of the equation of a circle, really is the distance formula. It really is a special case of the distance formula, because remember the definition of a circle is all the points that are this distance away from the center. So the circle formula looks a whole lot like the distance formula for a reason. It's really just a special case of it. So what I'm going to do is I'm going to take what I've got so far for that equation, which says, oh, I don't know what R is, so I'm just going to say it equals R squared. And what I'm going to do is I'm going to take that point on my circle and I'm going to plug it in. If it's a point, that means it has an X and a Y value, so I'm going to put in the X value for X and the Y value for Y. So what that gives me is 2 plus 5 squared plus 2 minus 1 squared equals R squared. 2 plus 5 is 7. 2 minus 1 is 1 equals R squared. So 49 plus 1 equals R squared, which is 50. Now if I wanted to find the radius, which I kind of do, I could take the square root of both sides. But the reality is I'm being asked to write the equation, and in the equation I want my R to be squared anyway. So if I did find the radius, then I would just square it when I put it in the equation. So let's just leave it squared. And say, okay, now I'm ready. I have this, except R squared is 50. So my answer is X plus 5 quantity squared plus Y minus 1 quantity squared equals 50.